We are now going to use the 4 methods that we discussed to perform some general conversion problems. Let's look at the first problem. We're going to take 99 pounds and change it to kilograms. We will do this using all 4 methods. The first method is the rainbow method, also known as the ratio method. We want to take 99 pounds and change it to kilograms. We're going to set this up as a relationship using a colon. We'll take 99 pounds, use a colon, and show the relationship to an unknown number of kilograms. We will then set this equal to what we know about the relationship between pounds and kilograms. We should have memorized that 2.2 pounds is equivalent to 1 kilogram. To solve for x, we will need to multiply our means and our extremes. We can do this simply by drawing a rainbow. We're going to multiply the 99 pounds by the 1 kilogram. We'll set an equal sign and multiply the inside of the rainbow, the x kilograms by the 2.2 pounds. To solve this problem, our goal is to get x by itself. Since x kilograms is being multiplied by 2.2 pounds, we will divide by 2.2 pounds to cancel out the 2.2 pounds and leave x by itself. Whatever we do to the right side of the equation, we need to do to the left. Notice that on the right side of the equation, both the number 2.2 as well as the unit pounds cancels out. On the left-hand side, only the unit pounds cancels, not the numbers themselves. We now can multiply 99 times 1, then divide by 2.2 to get the number of kilograms. We can now see that 99 pounds is equivalent to 45 kilograms. Another method we can use to solve this relationship is the proportion method. We will set up fractions to show an equivalency between pounds and kilograms. We're looking for the number of kilograms, so we're going to put x kilograms at the top of our first fraction. We're going to set this over the 99 pounds that we're trying to find the relationship for. We will then use an equal sign, create another fraction. Since kilograms is on top on the left-hand side, kilograms needs to go on top on the right-hand side. Pounds is at the bottom on the left, so pounds needs to be at the bottom on the right. We then ask ourselves what we know about the relationship between the units kilogram and pounds. We know that 1 kilogram is the same as 2.2 pounds. We can now use cross multiplication to solve for x. We're going to multiply x kilograms by the 2.2 pounds and set that equal to the 99 pounds times 1 kilogram. To get our x by itself, we need to eliminate the 2.2 pounds. As it is currently being multiplied by the x kilograms, to eliminate it, we will divide. Whatever we do to one side of the equation, we must do to the other. Notice that on the left-hand side, both the number 2.2 as well as the unit pounds cancels out. On the right-hand side, only the unit pounds is canceled, not the numbers. This leaves us with x kilograms by itself on the left-hand side, and we can multiply 99 times 1 divided by 2.2, and we can see that 99 pounds is equivalent to 45 kilograms. Now let's use the proportion method or the fraction method to solve the same conversion problem. We're going to convert 99 pounds to an unknown number of kilograms. To do this, I need to set a relationship in the form of a fraction between 99 pounds and our unknown number of kilograms. I'm going to put x kilograms in the numerator of our fraction with 99 pounds directly underneath it. I will then use an equal sign, create another fraction. Since kilograms is on top on the left, I'm going to put kilograms on top on the right. We can see that pounds is at the bottom on the left, so we need to put pounds at the bottom on the right. We then ask ourselves what we know about the relationship between kilograms and pounds. We should know that 1 kilogram is the same as 2.2 pounds. We can now use cross multiplication to solve for our x. We're going to multiply our x kilograms by our 2.2 pounds. And we will set that equal to 99 pounds times 1 kilogram. To get x by itself, we need to eliminate the number that is on the same side of the equal sign with the x, in this case the 2.2 pounds. We can see that the 2.2 pounds is being multiplied by the x kilograms, so to eliminate it, we need to divide. We will divide both sides by 2.2 pounds in order to isolate the x on one side of the equation. Notice that on the left-hand side of the equal sign, both the number 2.2 and the unit pounds are canceled out, leaving just the x kilograms. On the right-hand side of the equal sign, only the unit pounds cancels out, not the numbers. We now can multiply 99 times 1 and divide by 2.2, and we find that 99 pounds is equivalent to 45 kilograms. The third method to perform these conversions that we talked about was dimensional analysis. In this case, we're going to start with the number we're trying to change, the 99 pounds. We then want to multiply by a fraction that shows the relationship between pounds and kilograms. Since I want to cancel out the unit pounds, I need to put it at the bottom, and I'm going to put the kilograms on top. We know that 1 kilogram is equivalent to 2.2 pounds. Notice that by putting the 2.2 pounds at the bottom, I can cancel out the unit pounds, and I'm left with kilograms. We then can perform the arithmetic of 99 times 1 divided by 2.2, and we find that 99 pounds is the same as 45 kilograms. The fourth way to perform this conversion is the formula method. In this case, we will take the number we're trying to change, or the dosage ordered, this case 99 pounds, and we're going to place that over what we have on hand. In this case, it's what we know about a relationship between kilograms and pounds, and we want pounds directly underneath the 99 pounds so that the units will cancel. And we will multiply by what we're trying to change it to, in this case the kilogram. Notice the pounds cancel, leaving me only with kilograms, and then we perform the arithmetic of 99 times 1 divided by 2.2, and we find that 99 pounds is the equivalent of 45 kilograms. Now let's perform a conversion, changing milligrams to grains. First, we must ask ourselves what we know about the relationship between milligrams and grains. We know that 60 milligrams is the same as grain 1. First, let's perform this conversion using the rainbow method. We're going to set up a ratio showing the relationship between 0.4 milligrams and an unknown number of grains. We can write 0.4 milligrams, place a colon, and then to show the unknown number of grains, we use grain X. We will set this equal to our known relationship between milligrams and grains, making sure that the order of our units is the same as we put them on the left-hand side. Since we put milligrams first on the left-hand side, I'm going to put my 60 milligrams first on the right-hand side. And again, we know 60 milligrams is equivalent to grain 1. To solve for x, we will multiply our means and our extremes by drawing a rainbow. We're going to multiply the 0.4 milligrams times grain 1. We will set this equal to the inside part of our rainbow, grain X times 60 milligrams. Again, to get X by itself, we will have to divide by the 60 milligrams. And we must do this on both sides of the equal sign. This time we can see on the right-hand side of the equal sign both the number 60 as well as the unit milligrams cancels out, whereas on the left-hand side only the unit milligrams cancels. We now can find out how many grains are equivalent to 0.4 milligrams. To do this, we're going to multiply the top of the fraction, 0.4 times 1, to get 0.4, and bring down the bottom of 60. Now, if you perform this operation on your calculator, you will get a decimal. However, because this is the unit grains, we must leave it in fraction form. In order to get rid of the decimal in the numerator of our fraction, we need to move it one place to the right, which leaves us with the number 4 in the numerator. But since I moved it one place to the right in the numerator of the fraction, I needed to take the decimal in denominator and do the same thing. This now gives us 4 over 600. I can reduce this fraction by dividing by 4, both at the top and the bottom. When we do this, we find that 0.4 milligrams is the same as grain 1/150th. Now let's do the same conversion using the proportion method. We're going to set up a proportion showing the relationship between our 0.4 milligrams and our unknown number of grains. We're going to say that grain X is going to go in our numerator, and we will put 0.4 milligrams in our denominator. We're going to set this equal to another fraction that shows the relationship between grains and milligrams. Since we placed grains at the top on the left-hand side, we must put grains at the top on the right-hand side. The same goes for the milligrams. We ask ourselves what we know about the relationship between grains and milligrams. We know that there are 60 milligrams in 1 grain. We now can perform cross multiplication in order to solve for our X. We will multiply grain X times 60 milligrams and we will set this equal to 0.4 milligrams times grain 1. In order to get our x by itself, we must divide by 60 milligrams on both sides of the equal sign. Notice that on the left-hand side of the equal sign, both the number 60 and the unit milligrams cancel. This leaves us just with our x. On the right-hand side, only the unit milligrams cancels. This leaves us with 0.4 times grain 1 over 60. If we do this operation on the calculator, we will end up with a decimal for our answer. However, because we are solving for the unit grain, we must leave our answer in fraction form. We can multiply the top, giving us 0.4 times 1, 0.4, and place that over the number at the bottom, 60. We now have a fraction that has a decimal in the numerator. In order to get rid of that decimal, we need to move it one place to the right. However, whatever I do to the top, I must also do to the bottom. This creates a new fraction of 4 over 600. We then can reduce this fraction by dividing by 4 on both the top and the bottom of the fraction. And this shows us that 0.4 milligrams is equivalent to grain 1/150th. Let's do the same conversion using dimensional analysis. This time we're going to start with our 0.4 milligrams, and we will multiply by a fraction that shows a known relationship between milligrams and grains. We know that 60 milligrams is the same as grain 1. I want to place the unit milligrams in the denominator of this fraction so that the units milligrams will cancel. We know 60 milligrams is the same as grain 1. This leaves us with only the unit grain. We then can multiply 0.4 times 1, giving us 0.4 in the top part of our fraction, and bring over the 60 in the denominator. However, as we can't have a decimal in our fraction, we need to take that decimal and move it one place to the right to get rid of it. But whatever I do in the top, I must also do in the bottom. This creates a new fraction of grain 4 over 600. We now need to simplify our fraction, which we can do by dividing both the top and the bottom by 4. This shows us that 0.4 milligrams is equivalent to grain 1/150th. This conversion can also be done using the formula method. We will set the 0.4 milligrams directly over top of the 60 milligrams, which we know is equivalent to grain 1. By setting the problem up in this fashion, the unit milligrams cancels, leaving us only with grains. We then can multiply straight across the top, getting 0.4, and bringing the number 60 over for our denominator. Since we can't have the decimal inside the fraction, we're going to have to move it one place to the right to remove it, and whatever I do at the top, I will also have to do at the bottom. This gives us a new fraction of grain 4 over 600. We then can simplify this fraction by dividing both the top and the bottom by 4. This then shows us that 0.4 milligrams is equivalent to grain 1/150th. Now let's convert 2.5 milliliters to teaspoons. We must first ask ourselves what we know about the relationship between milliliters and teaspoons. We should know that there are 5 milliliters in each teaspoon. First, let's do this conversion using the rainbow method. We're going to set 2.5 milliliters to an unknown number of teaspoons. Making sure we keep our units in the same order, we're going to put what we know on the right-hand side. We know that there are 5 milliliters in each teaspoon. To solve for x, we need to multiply our means by our extremes, and we can do this by drawing a rainbow. We will multiply 2.5 milliliters times 1 teaspoon. We will then set this equal to x teaspoons times 5 milliliters. In order to get x by itself, we must divide by 5 milliliters on both sides of the equation. Notice that on the right-hand side of the equation, both the number 5 as well as the unit milliliter cancel. On the left-hand side, only the unit milliliter cancels, not the number. We now can perform the arithmetic, 2.5 times 1 divided by 5, and we find that 2.5 milliliters is equivalent to 0.5 or half a teaspoon. Let's perform the same conversion using the proportion method. We're going to set up a fraction that shows the relationship between 2.5 milliliters and an unknown number of teaspoons. We can say that x teaspoons are to 2.5 milliliters and set that equal to another fraction that has units in the same order, teaspoons on top, milliliters at the bottom, and we know that each teaspoon has 5 milliliters in it. Now to solve for x, we will cross multiply. I'm going to multiply the x teaspoons by 5 milliliters. We will set this equal to 2.5 milliliters times 1 teaspoon. In order to get x by itself, we must divide both sides by 5 milliliters. Notice on the left-hand side, both the number 5 as well as the unit milliliters cancels, leaving us just with x teaspoons. On the right-hand side, only the unit milliliters cancels, not the numbers. We can then multiply 2.5 times 1 and divide by 5 and find that 2.5 milliliters is the same as 0.5 teaspoons or half a teaspoon. We can also perform this conversion by using dimensional analysis. We will start with our 2.5 milliliters and we will multiply by a fraction that shows the relationship between milliliters and what we're trying to change it to, in this case, teaspoons. Since we want milliliters to cancel, we will put milliliters at the bottom of our fraction and teaspoons at the top. We know that 1 teaspoon is the same as 5 milliliters. We can now cancel out the units milliliters, leaving us only with teaspoons. We then will multiply 2.5 times 1 divided by 5 and find that 2.5 milliliters is the same as 0.5 teaspoons. We can also do this conversion using the formula method. In that case, we will take the 2.5 milliliters and we will use our known knowledge of milliliters and teaspoons to divide 2.5 milliliters by 5 milliliters and then multiply by 1 teaspoon. By doing this, milliliters cancels, leaving us only with teaspoons, and if we multiply 2.5 times 1 and divide by 5, we find that 2.5 milliliters is the same as half, or 0.5 teaspoons. Let's look at one final conversion before moving on. We want to take 3,634 grams and change it to pounds. In order to do this, we ask ourselves what we know about grams and pounds. We do not have a conversion factor memorized for these two units. However, we do know a relationship between kilograms and pounds. We can then ask ourselves, do we know how to change grams to kilograms? And we should. That's a metric conversion, and we learned how to move the decimal in order to do that. This problem is a two-step problem. First, we will change our grams to kilograms. Then we will be able to convert to pounds. In order to take our 3,634 grams and change it to kilograms, we have to remember what we know about the metric system. If we look at our 4 units, kilo, base, milli, micro, we can see that to change from a gram to a kilogram, we need to move our decimal 3 places to the left. Our decimal is currently behind the 4. We need to take it and move it 1, 2, 3 places to the left, creating 3.634 kilograms. As we know, kilograms must be rounded to the tenths place, so this gives us 3.6 kilograms. We then will set up a relationship showing 3.3 kilograms to an unknown number of pounds. As we have already reviewed, we know that 1 kilogram is equivalent to 2.2 pounds. We then can multiply our means and our extremes to solve for x. We're going to multiply the 3.6 kilograms times the 2.2 pounds. We will set this equal to x pounds times 1 kilogram. In order to get x by itself, we must divide both sides by 1 kilogram. On the right-hand side of the equation, both the numbers 1 and the unit kilograms cancel, leaving us just with our x pounds. On the left-hand side, only the unit kilogram cancels, and we can then multiply 3.6 times 2.2 and divide by 1 to find our number of pounds. When you use your calculator, you end up with 7.92 pounds. However, we will round this to the tenths place, so we find that 3,634 grams is equivalent to 7.9 pounds. We can also use this conversion by using the proportion method. We need to change 3,634 grams into pounds. Since we do not know a relationship between grams and pounds, we must first change the grams to kilograms and then convert to pounds. Remember from earlier that in order to go from a gram to a kilogram, we must move our decimal 3 places to the left. Currently, the decimal is behind the number 4. we can move this 1, 2, 3 places to the left and discover that we have 3.634 kilograms. However, since this is the unit kilograms, we should know that we need to round this number to the tenths place. 3.6 kilograms. We then can create a fraction so that we can convert 3.6 kilograms to an unknown number of pounds. We will do this by placing x pounds over 3.6 kilograms. We then will place an equal sign and another fraction, placing pounds in the same position that it was on the left-hand side on top and kilograms at the bottom. We know that 1 kilogram is equivalent to 2.2 pounds. We then will perform cross multiplication to solve for x. We will multiply x pounds times 1 kilogram and set that equal to 3.6 kilograms times 2.2 pounds. In order to get our x by itself, we must divide both sides by 1 kilogram. Notice that on the left-hand side, both the numbers 1 and the units kilogram cancel. This leaves us with just our x pounds. On the right-hand side, the unit kilogram cancels, but not the numbers. We then can multiply 3.6 times 2.2 and divide by 1 in order to get the number of pounds. By using your calculator, you will discover that this equals 7.92 pounds. We should know that we need to round this number to the tenths place, giving us 7.9 pounds. We can also do this conversion in a third method by using dimensional analysis. Since we are trying to go from grams to pounds, and we do not know a conversion factor for that relationship, we must first convert our grams to kilograms and then to pounds. We should remember that to go from grams to kilograms, we must move our decimal 3 places to the left. We will take the number 3,634, which has a decimal after the 4, and move it 1, 2, 3 places to the left to discover the number of kilograms. Remember that kilograms must be rounded to the tenths place, so this gives us 3.6 kilograms. We now will take our 3.6 kilograms and multiply it by a known relationship between kilograms and pounds in order to convert it. Since we want to cancel out the unit kilograms, we will put it at the bottom, and we want to get pounds for our answer, so it will go on top. We know that 1 kilogram is the same as 2.2 pounds. Notice our kilograms cancel, leaving us only with pounds. We then will multiply 3.6 times 2.2 and divide by 1. This gives us 7.92, which we will round to the tenths place for our pounds. We discover that 3,634 grams is equivalent to 7.9 pounds. We can also convert grams to pounds by using the formula method. Since we don't know a relationship between grams and pounds, we must go through the unit kilograms. We will first change our grams to kilograms, and then use our knowledge of conversion factors to change kilograms to pounds. We should remember that to convert 3,634 grams into kilograms, We need to move our decimal 3 places to the left. Currently, the decimal is behind the 4, and we can move it 1, 2, 3 places to the left to find our kilograms. Remember, kilograms must be rounded to the tenths place, so 3,634 grams is equivalent to 3.6 kilograms. We then can set up our formula to change 3.6 kilograms into pounds. We will take our 3.6 kilograms, divide by the 1 kilogram so that the units cancel, and multiply by our 2.2 pounds. The kilograms cancel, leaving us only with pounds, and we can multiply 3.6 times 2.2 and divide by 1 to get 7.92 pounds. We will round this to the tenths place, and we discover that 3,634 grams is equivalent to 7.9 pounds.